bad, I was on the wrong week there. So you're going to actually change what's called the guess my number function. So one of the things I have seen before when we had programs where we said you need to modify this code base is some students wanted to recreate that code base on their own. And that's great. I like that initiative. But the reality is they're all tucked over here under this course documents as a working base. So if you need a place to start, look at week 3, I believe it is, to get that sample for guess my number. So I do have a couple of samples in here, so you can look at samples of other ways students did that. So what we want to look at is functions, obviously. So we've got a lot of pieces we've put together. We've got all these operands, and we've learned about strings and numerics and data types and all different kinds of things. We want to work with the idea of functions. And so I'm going to look at a function here, and we're going to look at kind of a basic structure. So I'm going to start a brand new one. And anytime I start a brand new one, I'm always going to make sure I have some content up here. So sample function. What we want to do with this idea of functions is we really like the idea of abstract, so that I am making my program as abstract as possible so that I can say I'm going to run my program, and my program has, so I'm saying I get a name, pass name to function, and I want to be able to put it almost in that kind of that pseudocode, that high level where I'm not worried about details. And so one of the things we're going to do is our functions generically for now. So if I define a function, and I'm just going to call this sample. So I've created this function. I've got it up here, and we're going to call it sample, whatever we wanted to call it. Those all set at the beginning of my program here. And maybe I have a couple of those. Maybe I even just call this one sample 2. But what I've started to do, what we'd like to do eventually, is we would like to modularize the entire program so that all our main program itself, so the program that actually runs, all it does in some cases is call one function. No. And so in a lot of cases we actually do it this way. So we define main. Now in this case I'm not passing anything in, and so program. And so the only thing that's not in a function is here where we call the main, and then at the end where we put our input in to hold that program open. Because we haven't found a better way yet to really get around that idea. So this gives us the ability to put that entire program in a function. So the only thing in our main so this is our main program. So these functions, no matter who's printing in the lab. So the only thing that happens here is those functions are all setting up there all by themselves. So we could actually, and we'll show you fairly quickly how we can do that, we could put those even in a different file. They don't have to be stored even with this. We could actually reach out and say, we're going to go out to another file and we're going to get those particular functions. The only exception to that, and it just has to do with the way Python works, most of the time, to make sure that it works, I tend to put my imports right up here. So if I'm putting in a random or any other functions that are pre-built libraries of functions, I just tuck it right up here. And I put it above where I'm starting to define functions. So in this particular case, I've imported random, and maybe my main program then we call sample, and then we call sample2, and maybe then it calls sample1 again. So this structure is really, really common. And so I want to look at that structure and make sure I see how that works. So our main only calls this particular function. Now, what this also lets me do then, if I want to run this entire program 5 times, is there an easy way to do that? What if I just did this? Because now that all I'm doing is calling that entire program for x in 1, 2, 5. And now I'm running that main program 5 times. Now that's kind of an odd example, but I could certainly have it loop that main program so while input does not equal 0. And so I could create a loop very quickly. And now everything inside that program is dependent on an input statement. And so we could loop this entire program really, really easily. The other thing that happens when we think about this in terms of modular construction is maybe my idea in here is only part of a bigger program. So we're writing the tic-tac-toe function. So this is the tic-tac-toe game, but your fellow coders are all writing other games, and you want to bring up a menu of 10 different games to run. And so you could certainly do that then from this idea. And so you could start making that idea of I can break programs into chunks and then I can combine them. And so now when I start looking at programs and pieces around me, I start seeing those ideas of, hey, this is a module for how to send a file. And Python is a pretty stout program. So probably one of the most famous ones that you've seen and you may have used is most of the back end of Dropbox, and in fact most of Dropbox is written actually in Python. And that's certainly a fairly robust, large program. And it's all broken down into these modules. So when I click Get Dropbox Basic, it calls a module. I don't have all of that in one string of mainline programming. So I want us to be aware of those kinds of structures as we start to look at this. Oh, I've lost the right one. There it is. So that data structure, all of our content is really contained within functions. It makes it modular. That way, if I'm calling different functions, so I call a tic-tac game and it crashes that module. It doesn't crash the entire program. And we're going to work on some ways to avoid and future-proof some of that crashing. So on page 162 in your book, they talk about abstraction. So make sure that you have read about abstraction and you understand that. We look at encapsulation on page 165. (166). So any of these things where they have it in like a block, make sure you read and look at that because that really does give you an idea. So that idea of reuse or finding the best model. Once we do something, we do it really well and we've created code. For example, the ask yes or no function that we've already created, we can reuse it over and over and over again. So make sure that you have done, on page 172, is a program called Global Reach. Make sure you've recreated this on your own and that you understand that idea of how those functions take arguments and it's either an internal or it's external to that function. And make sure you look at that. Because if you don't, it's going to be very confusing. How do we pass data in and out of those functions? So that is literally the hardest piece of this. These functions probably make sense. Getting data in and out of them is where it gets a little harder. So we're going to look at the tic-tac-toe game. And so on the top of page 176, 176 is really this idea of something called pseudocode. So we've all done pseudocode, but now that we have these functions, now we can think about what we're really doing with pseudocode is calling each individual function. And so the pseudocode says each line essentially is one function. So display the game instructions. Well, we could create a function to display the game instructions. Okay. Determine who goes first. Well, that sounds like a function. Figuring out whether it's you or the computer. Create an empty tic-tac-toe board. And then we display the board. But then we look at it creates a loop. While nobody's won and it's not a tie, then we create some of that logic of how tic-tac-toe works. We've all played it. We all know how it works. Now we're just formalizing that logic. So we really have an if statement. So if it's the human's turn, get the human's move, update the board with the move. If it's the computer's turn, or the else statement says, calculate the computer's move, update the board, display the resulting board. So in other words, we update the board in either case, where those positions are, and then we display it. We crack a flip, so we say, now it's the computer's turn, now it's a human's turn. And then we either repeat that loop, so that loop says if nobody's won or it's not a tie, and otherwise we congratulate the winner or declare a tie. All right. So we're going to go through the pieces of this. Bottom of page 6.9, it shows a grid. And one of the things that we have to remember is we think graphically, the computer thinks numerically. And so we're going to assign this grid, and we're going to assign a space number to each one of those. Page 176. So on page 177, there's actually a table of all of the functions that we have in this particular game that we built. So ahead of time, looking at that pseudocode, there's an idea of what those functions are. And so display instructions, and display instructions is a void function. In other words, that makes sense. It doesn't take in any data, and it just displays things up on the screen. Our ask yes or no question, so the same function we've looked at, and we'll see that it looks very, very familiar. Asks a yes or no question, receives a question, returns either a lowercase y or an n. So we've built that function already. we already have that one. Well, then we're going to change it to an ask number question. And that ask number question takes in 3 elements. It takes in your question, and it takes in a low and a high value, and then returns a number that's within that range. So in other words, if you put in, I want to put in position 10, an X, this is the function that we're going to use to check that. We have a function called pieces, and that just determines who goes first. We have a function called new board, and that creates a new empty game board. We have one called display board that takes whatever that content we have and displays it. We have a function called legal moves. And legal move just says these are all of the legal moves. In other words, what we're really looking at is what's left on the board. Then we have the winner board. So it determines the game winner. The human move. And the human move, notice, takes in board and a value from human. Computer move takes in a value of board, a value from computer and human. Next turn function just switches pieces. And then we have a function called congratulate the winner. All right, that sounds like a lot, doesn't it? But if we break it into pieces, this is that idea of that modularization, because this is going to be by far the biggest piece of code we've created, but we actually can do some of this ahead of time. We already know what it is. We break it down into some of these functions and things. So let's create tic-tac-toe. And we're going to do a couple of things. So just like I said up here, we almost always put in import random. There's a couple of other things that are useful to have at the top of our file. So I'm going to just make this the full screen. Oop. This way. File new. Move that one over. All right. So a couple of things we know we want. And what we're doing, we're creating tic-tac. All right, so one of the pieces we tend to put in up top, above the functions, if we have values that are going to be used throughout the program. So that idea of our constants. And again, Python, for good or bad, doesn't actually have true constants, but by using the construct of capital letters, we understand what it's doing. We could change them in the program. Hopefully we don't. So I'm going to create one. So this is my constants. And so I'm just going to have a couple of them are just placeholders. So x equals x and O equals. So when we display the board or we display them in a question, we have those already in there. I'm going to have one called empty. And so it's just a blank space. I'm going to have one called tie. And we're going to create one called num squares. So the number of squares is equal to 9. So in theory, we could take this game and we could create a new version of tic-tac-toe with 4x4 or something else, but how we would do some of the scoring, we're not really sure yet. So I'm going to do some of these functions, and we don't necessarily need to do them in the same order, because the first one I want to do is one we've already seen up here. So I'm going to create one. I'm going to say, here's my functions. And the first function I'm going to do is I'm going to actually create my ask yes or no function, because it should look kind of familiar at this point. And in fact, once you've done this a couple times, guess what? You can copy and paste that in there. So copy and paste question. So it takes in the value of question. And what it does, response equals, we set it equal to that, null. Notice it lights up orange, so we're on to something there. And then while response not in, and here is where we get the ability to do some other things. So we'll create this and then we'll look at it really quickly. So while it's not in, lowercase yes or no, forgot my colon, response equals input question dot lower. In other words, we take the lowercase values of that. Now, one of the things we said as a suggestion was there is a way we could probably make this even better. So if they typed in yes, we could use that slice function and just take the first letter also. So we're also then going to return that response. That response can only be a lowercase y or a lowercase n. And the reason it can only be those is we have set up this loop so it will never exit this loop unless it gets either a lowercase y or a lowercase n. So it's fairly robust from that standpoint. We could probably make it better. Now, what I don't have in here is I don't have the triple quote in here. This function and we don't care what the questions are, but that's another way we can document this so we can see that, yep, that is a function that really is a yes or no question. So that one's really common. No matter what question we pass into it, and we find in a lot of our programs, we ask yes or no a lot. And so think about when you interact with MyPSC. Is this what you really want to do? Yes or no? Is this what you want to do? Yes or no? So we see those kinds of things a lot. So since I created a yes or no function, I'm going to also really quickly look at the one for ask a number. So we need to figure out how to get a number. So ask number. And this one also is we're going to pass in a question, but we're also going to pass in a low and a high because we want to ask a question and we want to have it in a range. So we want to be able to ask for a number and we want to keep it within a range. And so you get to pass those values in. And so again, we're going to use some of this very similar structure. We're going to use this response equals none. And so I'm just going to go up here and copy that out really quickly. As we do that a lot, we say response equals none. So really that sets response to a null value so that we know our while loop, while response not in range, so we do a couple of things here. So we're passing in that low and that high, and we're saying while it's not in range. So this first time, when it is a null value, it's automatically going to be not in range. So as long as this loop will function as many times as it need to, so response equals an input question. Now, we have to do one more thing because all of our inputs automatically come in as a string. So we convert it to an integer because we're looking at a number and we want to have it in that range. And then we're going to return response. So if we think about what this is going to do, you're going to pass in, please enter a value between 1 and 9. You pass in the values of 1 and 9, and then it looks for a value that's in between there. If you passed in the values of 1 and 100, it would work for that also. We could hard code it. We know in this game that there's only 9 squares. We could hard code this kind of stuff, but this allows me to reuse this in future projects. So if I need a number in a specific range, wow, now I have a function I can just grab out of my code set and I can implement really, really, really quickly. So the first function, if I go back and look, is actually the display instructions. And the display instructions has a lot of details in it. And so I'm going to do what we call cheating. Because I don't really want to copy this entire triple-quoted string. So I'm going to cheat and I'm going to say, all right, instructions, define, display, instructions. And it's got a print statement. I can't type. RUC10 for the game. And it's got a print statement, and I am going to actually just grab this right out of the completed code. Now, I can change it, I can manipulate it, whatever I'd like to do, but I don't really want to recreate it right this second to save some time. So, welcome to the greatest intellectual challenge of all time, tic-tac-toe. This will be a showdown between your human brain and my silicon processor. You will make your move known by entering a number 0 through 8. And so they've got the board printed here. The number will correspond to the board position as illustrated. Prepare yourself. The ultimate battle is about to begin. Moves it down a line. And so all that does is display those instructions. So we have our constants, we have our display instructions, a yes or no function. So if I go back and I flip back to page 176, I can look and say, all right, so I've created 1, 2. I need to look at the function for pieces. So pieces, if I look at its description and what it's going to do, is determines whether you or the computer goes first. So come down a few lines so I have some space and you can see it. We're going to create another function and we're going to call it define pieces. Now, again, it's not taking in anything. Nothing comes into this function, so now we're going to ask a question. So the function says we're going to ask who gets to go first. Because we know that X's always go first. Just like on a chessboard, black always moves first. Is that correct? No? White moves first? Okay. So in this case, X goes first. So if you select you want to be the first player, this determines whether your X's or O's. And so we're going to create a variable called go first. And all we're going to do is we're going to set that equal to, and now, here we're actually going to call a function from within a function. So we're going to call our ask, yes, no function, And we're going to pass in, do you want to go first? So this is going to pass into our ask yes or no function. So we're calling it, and so it's going to run this entire thing. So what we're going to get out of that is either a y or an n is going to get assigned to go first. Does that make sense? Yeah. Do you want to go first? Please use only y or n. Now, I'm putting that in here. Is there a better place we could put it in here? I think we actually could. I think we could put another line in there to make this a little better. So we could put a print statement here just to help out our silly humans. So we just improved it, made it a little better. Now I don't have to put this in every time. I can just come in here, and it's actually going to print that and then ask your input question. So now we have a value back. And we don't have to go through that loop or make sure. It passes up and it takes care of that for me and gets a response back. So now we can get a logic piece in here. So if go first is equal to yes, so now what we're doing is we're going to assign human equals X, computer equals O. So we're just making this assignment. Now, we're going to embellish that a little bit, or we can. Print take the first move, puny human player. So you could come in and put snarky comments or whatever you'd like. So if that is true for if the human wants to go first, so then an else statement we could put in, and we could say human equals O, computer equals X. And you could do the same thing if you wanted to. You could put in some kind of a snarky comment. So you could put in some snarky comments. In this particular case, this program needs to return something. And so what this particular function is going to return then is it needs to return two values. So we created them here, human and computer. So it's going to return computer and human. Bless you. So this function passes in a yes or no. Based on that decision, we know whether the computer is assigned X's or the human's assigned an X. So we assign a piece to them, and we know who goes first, second, third, whatever. All right. So the next piece we're going to do, based on our chart back here, is we're going to look at defining the board, if I remember correctly. So we need to create a blank board for this. So it's got no values in it. But if I'm going to create a board for something, and I know that I really need something with spots of 0 to 8, and they need to hold a value, what might that be? I need it to be mutable. So it's not a tuple. What's the other data structure we have? A list or an array. So I'm going to store data in an array. And so define new board. So create a new blank. So what we're doing with this is creating that data structure that we're going to do that. So the first piece I'm going to do is I'm going to create a list called board. And notice I use the square brackets. That makes it a list. That makes it mutable. So we're going to set all of those values in there equal to empty. So I could have created this and said, well, all right, empty. And I could put in all 9 values in that way, right? Comma. And I could do that for all 9. But we're going to go through, because I want to have that idea of maybe I expand this at some point to that 4x4. So empty equals blank. So we just want to put blank values in there. So we're going to do this. We're going to do a for loop for square in range. And we're going to pull one of those global values or those constants. So in that range of number squares, in other words, we know it's going to be 0 to 8 because it's 9 values. We're going to use board.append. So that same function that we could use to create those 10 and 15 variables we had last week. And we're going to pass in whatever's in empty. And this function, so now what that did is it took and put a blank space in each one of those. It created an empty board. There is no content in there. So the reality is, most likely that entire data structure would have been empty to start with. We just made it, kind of went through a safety plan, and we put a blank space in each one just to make sure it's going to work for us. And then we're going to return that value of board. And notice that return, I don't have to specify that it's a list. Python takes care of that detail for us. So Python doesn't care if it's a list of variables or an individual variable. I just have to return it once to get us in there. So Python does a lot of those things for us. So the next piece we need to do is we want to be able to display this board, whether it's empty, whether it's full, whatever it's got. So I'm going to create a function called display board. And to display that, I need to get board in there. And so this one's going to take the value of board. This displays the board for all to see. All right, so this is really nothing more than a set of print statements. And you could actually do this in a ton of different ways. The easiest way, probably, at least because we know we only do 9 squares, is we're going to print each one. And by using new lines and tabs, we can create a board that looks like it does right here. So we're going to create something very similar. So we're going to get the value of board in position 0. And then we're going to put in the pipe character. And if you don't see that on your keyboard, it's 2 characters above the shift key on the right-hand side. And then we're taking the value of board 1. And then we're going to put in another pipe character. And board position 2. So we have 0, 1, 2 on the top. Now, to separate that line, then I'm just going to create a print. And I'm going to tab over, so I'm one space in, so I'm going to do a tab. And then I'm going to put in 9 spaces, I think it is, across there. I could be wrong. 3, 4, 5, 6, 7, 8, 9. Should work if I counted correctly. All right. And so that looks like a lot of work. I'm going to make my life a little easier because now that I've got that in place, I'm going to do this. I'm going to copy and paste. And now I'm just going to change those values to 3, 4, 5. I'm going to copy it one more time. And that would be 6, 7, and 8. And I copied this, but I don't need that at the end. I only need that separator once. Now, the other thing I'll do just to push it down at the end of this line is I'm going to add a new line character at the end of that. Just to make sure it starts a new line and forces that down one line. So, display board. And I can try this. So one of the things I can do is we could actually run a function to see what it's going to look like if you wanted to. We can do that really easily. So one way we could do it without even calling the function, I just copy that whole block, I paste it in, and then I see, yep, we want to save it, and I'm going to save this as tic-tac-toe. And it's going to give me an indent error of some sort. Oh, because I have all those. Okay. So you can see, is this going to look like what I think it's going to look like? You could even go File, New, and paste it in here to see if it's right. And you could run it just on. And so a lot of times when I have a function or a piece of code and I want to try it, I will actually post it into a new piece. Now, if there's variables involved, then you obviously have to do those also. Because right now, it's going to return, hey, well, I don't know what's going on here. So if I try to run this, watch what happens. Call it tac. And it's going to go, why? This doesn't make any sense. There's nothing here. Because it doesn't know if there's a variable there or not. So, but we can try that and we can see. All right, let me go back and find my. All right, so we've got a couple of the pieces. We've got the tic-tac-toe board. We now need to think about what can I do? What can I do for determining if a move is legal or not? And so when we say legal in the regards of this particular model, we're saying, is that square open for me to play on? Because that's the only restriction. We don't have any other restriction. X's can't go in only odd squares or any of these other rules. But all we want to do is find out, if they're equal to empty. So legal moves we're going to have a function called legal moves. The easy way to do it on this particular game, not logo moves, legal, is we have to take in the value of where that board is at, because that board, as the game progresses, changes. We change some of them to X's, we change them to O's. And we're going to create another data structure. And so we're going to have another array, and we're just going to call this one moves. You could call it legal moves. And here is how we're going to determine if they are empty or not. So we're just going to create, and that square doesn't have any value, it's just one we're assigning at this point. In range. So this should look really familiar. So in other words, we're just creating a for loop that's going to go through all 9 of those boxes. And then we're just going to put an if statement in there. If board so as it's going to go through, it's going to go for board 0, board 2. If it's equal to the value of empty, then we're going to do something. Otherwise, if it's not empty, board doesn't get a value. If it's empty, we're going to put it in there. We're going to use that same function. So moves.append. So we're going to add a value. And we're going to add the value of square. So what this is going to create is a list of all of the places on the board that are empty, that don't have a value. And then we're going to come back out here and we're going to return moves so we can then see it. So when you put in a square, you're going to compare it against this particular function. So the next function we're going to have is the winner function. So the winner function, we need to think about our tic-tac-toe board. And that tic-tac-toe board, there's only a limited number of ways that you can win. And I know we have at least one math student in there. How many different ways are there to win at tic-tac-toe across the board? So there's 3 horizontal and 3 vertical ways, right? So if I have the top row, middle row, or bottom row, or if I have the left column, right column, or middle column. So that's 6 different ways. And then the 2 diagonals. That's the only ways we can win. And so we're going to use that as a structure we're going to have. So we're going to define winner. And this function winner is going to take in the value of board. So we can check it. So it's got to take in board. And inside of this function, so inside of this function, we need to have some way to tell if we've won. And so we're going to create another constant, ways to win. And so this is one of those where we have to think a little bit about it. And in this case, because it's a constant, and that's great, I don't want to do it, I'm going to use a tuple instead of a list. I could use a list. In this case, it probably doesn't really matter. But that list is going to have a set of values. And so 0, 1, 2. So that's the top row horizontal. So if that works, then I need 3, 4, 5. So the middle row. And the bottom row would then be 6, 7, 8. So that's my horizontal ways to win. My vertical ways then would be 0, 3, 6. And then 1, 4, 7. And then 2, 5, 8. And then lastly, our diagonals then would be 0, 4, 8. And our last diagonal, the other direction, would be 2, 4, 6, I believe. 2, 4, 6. So all we did was construct a constant that we could look at to see if those things are actually the same. So now we need to check against that. And so those for loops are a really good way to do it. To win. So here we're checking against, so if board, this is kind of the ugly piece here. So row, square, row 0, is equal to board row 1. Is equal to board row 2. Not equal to empty. All right, that's a mouthful in that if statement. So you're trying to see if those particular values in one at a time. So row 1, 2, and 3. So we've set that up as 1, 2, and 3. Or 0, 1, 2. So 0, 1, 2. So what we're doing is comparing every possible combination of that to see, and it can't be an empty value. So winner equals board row if it is, then we return winner. So in other words, what we're searching for here on this last statement then is it an X or an O? All right. We also have a couple of other pieces we need to think about. So if empty, not in board. So in other words, if we don't find a value of empty, then we're going to return the value of tie. If none of those are true, so in other words, if we don't win, and the board doesn't have any empty spots, that means we can play another hand, right? Or another round. So if that's the case, we're going to return the value of none. So this is a little more complicated than what we've done previously. So we're checking through that entire board. We're seeing if we won. If there's still moves available to play, then we're going to go up here. Now there's other ways we could have done that. Depending on when we change that one here up here called moves, I could also check through moves. And if moves is empty, in other words, there's no values in moves, that also tells us we're out, and we could have used that as a method. So there's usually some multiple ways we can do that. All right. Now we need to get the human move. So define human move. And human move takes in a couple of things. It takes in board and it takes in human. And remember, human is set to either X's or O's. So we need to know which one it is. And I am going to look at then, so legal is equal to legal moves so we're going to pass that board in. So move equals none. So in other words, we're going to use that priming the pump cheat here. And we're going to put in a loop. So while move not in legal, move equals, and here's where we use that function again. So we're going to use the ask number function. Ask number just to remind him it's 0 through 8. Now, we also need in that ask number function to pass in a low and a high. So we know the low's 0, and the high is equal to that num of squares. So we're going to pass in 2 values into this function, or 3 actually. So you're going to pass up this question. You're going to pass in 0 and number squares. And I will say that right now I cringe when I'm looking at how they've done that, because here's what I would do. I would way up here, since I know I'm going to type in low, and I'm going to set that equal to 0. Because I hate when I look at code and I have this random number in here that doesn't make any sense. So I'm going to change that already out of what our book example, and I'm going to set it equal to a variable so that I don't have a mystery number. So it's still 0, but when I look at this code, I don't go, what is this mystery number that I don't know what in the world it is? I'm then going to ask if move not in legal. So in other words, you're trying to go either to a square that's occupied, because their function here is only going to return the values of 0 through 8. So if you put in 12, I'm never going to get to this point. So 12 will get weeded out in my function. It's going to loop back again and ask for a question. So I could put in the snarky print statement. So you could say something like that. Then if that move is acceptable, we could put in thank you for you could put in something like this. So that print statement, and then we're going to return out of this function the value for move. So all we're doing is checking through to make sure it works. We pass it into our function to get the value. And I had my own little personal little crisis with the mystery number. Mystery numbers are generally bad, and we try to avoid them. All right. So probably the hardest piece of this, is actually determining if the computer and what the best move for the computer is. Well, we know what we would do first. So what's the best square to go to on the board? If I'm starting out, what's the best square on a tic-tac-toe board? The what? The center. So the computer is going to look at that and try to go into that first. So we're going to look at a way we can determine that. So we will start on Thursday determining the computer